All right. Now, let's talk about access modifiers. So in Java, there are 4 types of access modifier. We have the default type, which is not writing an access modifier at all. And if you do not specify which access modifier it is, then it will be a default one, which is a package access. That means the class in the same package can see your file, alright? Or your variables. Alright, let's say if you do not specify any access modifier for your variable will be seen in the class that defines it and in the same package or other classes in the same package will be able to see it. Alright? And we have seen private, where only the code within the same class can see the variable. Alright? And we also have protected and public. Protected means size in the same class, in the same package, and in subclass can see it. Right? You will see protected being used quite a bit when we learn about inheritance. Right? And public is when anywhere can see your variable. Alright, so we have these 4, and apart from being an access modifier to variables, they can be access modifiers to methods and this. Alright, in the UML diagram, you can see that the minus sign is for private, curly sign is for package access, and the hashtag sign is for protected. Alright, and the plus sign is for public. Alright, we have seen an example on private access modifier before, right? When we deal with the car example, right? So this slide is just a reminder. Okay? It's just a reminder. If you make your variable private, then another class cannot do a direct access to your variable. That class has to use the method that you provide in order to read and write that variable. So that's the thing that we have seen in previous example. And in order to allow the user of your class to be able to modify the values, they have to use your provided methods. And the simple provided methods are getters and setters. Alright, and we've seen the example. So this is just a reminder, okay? With dice as an example this time. Right? So we have getters, setters, and we have 2 strings, which you've seen an example 2. Okay? So the next part is to be able to define whether 2 can be regarded as equal. Alright, let's see an example. Right, let's see. All right, I will go back to the car example. I think that one's easier. Why? Oops. Oh, this one has an example. So let's see. Okay. The example here has simple dice tree. Right? Simple dice tree is very much like simple dice. Has get and set. Okay. And it has method equals and hash code, which will be used for comparing to simple dice, but I will remove for now. Right, I will remove them for now. And we'll go back to the test of simple dice. Here, I create simple dice tree, called, well, the first one is called S. The second one's called A, and the third one's called B. All right. Well, to simplify it, I'll just have A and B. Okay. And they have the same face value. All right. They have the same face value. So we print their face value, and I'll first test if they are equal this way. I'll test by using the equal sign. And let's see what happens. Right? Is A equal to B? Well, they have the same face value. But what will the program say? It's false. They have the same face value 1. See? That the equal return false. That's because the equal sign test if they are the same address. Right? So you got A and B, which, well, although both are simple dice tree, they are at a very different address. Right? If I draw what happened here. So what happened here, if I draw, let's draw it. Let's invoke the paint. Right? So A contains object of type simple dice tree with value 1, right? And B is a different variable. Stores are different block of memory location with value 1 inside. So they are completely different entity. The equal sign paste whether they store the same address. But clearly they're not storing the same address. So that's why the equal test returns false. What if I change it to use the equal method? What will it return? So let's run with equal method. Is it still false? Run again, just to be sure. Still false. Equal by default uses equal sign to compare. Alright, so the result is the same. So if you want to consider these two to be equal according to their content, you will have to write the method equal by yourself. Okay? You have to write the method equals by yourself. So what we do is in simple dice tree, right? We are back to simple dice tree. I can generate equals and hash code. And I can choose what kind of operation that I want to use to test if the thing I want to compare with my simple dice tree is also a simple dice tree. Alright, you have two choices here. I'll choose instead of, and I'll explain when the code is generated. Alright. So, next, choose the fields that you use to compare. So, these are the fields that you will use to compare if the two objects are equal, right? Instead of comparing the address, you compare the content in these fields instead, right? So, compare their properties. Right. Face value. Next. In hash code, also choose face value. Hash code is a method that when you apply to an object will return a unique value for the object. Alright, so if you consider two objects to be the same, then their hash code should be the same value. Alright? So two objects can have, if you regard them as being equal, then their hash code should return the same value. Alright, so let's create. So we have created equals and hash code here. Okay, so hash code will return an integer representing your object, and it generates the integer using the value of property face value. Alright, so any simple dice tree with the same face value will give out the same hash code. Okay? Right. What about equal? Equal is a method that you use to compare two objects. Alright? By default, it's written for class object. That is the superclass of every class. So in order to use equal, you will have to write it in the same way as it was written in class object. That means your method equal must take the argument as object. Alright, if you use other types as argument, then your equals will not be regarded as the equal method that the system will use by default. Alright? By default, the system only use equals defined with object as argument. Alright, so remember that. So in the code here is object O is not simple dice tree. Return false. Alright. And main the object O that rename it that and make that being type simple dice tree. Alright, because O is an object. See? O is an object. To be able to actually extract the field face value from O, you can't directly access it from O. Right? Can't do it. So you must convert O to simple dice tree. And one way to convert it is to use this instance of and then that at the end. And that will be the variable that represents your O. Okay? So if O is not simple dice tree, return false. Then if it's simple dice tree, then compare the face value of O with the face value of this object. Right? This object is calling equals to compare itself with O. Okay? Right? Or, well, instead of doing this, you can do something like if O not O instead of simple dice. Sorry, I should really type it down. So alternative rate, you can write if not right or instance of simple dice tree. If not, then return false. Else that okay. If this is not, then right, then else. Let's name it that as well. Simple dice tree f equal to O cast it to simple dice tree. I'll comment this out first. So it prevent conflict with names. Okay. Then face value equal to that dot face value. Right? So alternatively, if you are not comfortable with writing this statement, you can just simply compare them normally and then cast O to simple dice tree. Right? Right. So that's the thing to do. All right. If there's a warning here, maybe I can rename it. It's still, well, what's pattern variable? Oh, I see. The warning is the way that the tool suggests I should code it. But it just did the same as the line here before, which I don't want. Right? Okay, but logics the same. Logics are the same. So this is equal. All right. So O instead of simple dice tree means O can be regarded as simple dice tree. Alright? If O is regarded as simple dice tree, then compare the face value. If not, then just return false right away. Okay? So that's our equal. And now, once we have written this equal method, let's get back to the test. Use simple dice tree. This equal should now return true. So let's run it. Because now the equals method compare the face value of A and B instead of comparing their addresses. Okay? So that's equal. And you will have to write equals method for an object that you want to, compare with other objects with their fields. Alright? Let's get back to our slide. In the slide, there's one more example. It's in class simple dice 4, I think. But in that class, it's a bit strange because the equal that compares simple dice 4 does not compare with another simple dice 4, but it instead compares with anything that can be converted to dice. So that means equal for simple dice 4 in the example there won't compare simple dice 4 object with another simple dice 4 object, which I think is a bit strange. But anyway, there's the example where you cast 2 dice right away and then compare the face value of the dice with this object. Alright? Okay, so, but I think this is not a good example, but it just shows that equals can be written in any way that you want. Okay? Right. So, equals. If you want anything to be equals, remember that 2 things can be equal. No, not 2 things. Equals mean they will have to have these properties. We have to have reflexive property. That means X must be equals to X. Symmetric, which means if X and Y are equal, then X equal Y should return the same result as Y equals X. Alright? Transitive means if X equals Y is true and Y equals Z is true, then X equals Z must also be true. Something like that. Alright? And consistent means if X equals Y return true, then it must always returns true if nothing changes. Alright? And if it returns false, it must always return false unless anything changes. Okay? So, that's it. Alright, and nothing can equals now, because now cannot call method equal. Alright? So we can't call now equals now. It's impossible. Right? So X equal now will never return true. Okay? I think that's it for equals, and that's the table for equal. Alright? Right. So that's it for this topic.